discuss theory part, magnetic effects of current. Magnetic effects of current. There is a one question. That a question is very important question. There is a 5 more questions. 5 more question. Magnetic field at a point due to long infinite current carrying conductor, often asked in the board examinations. So very important question in the topic magnetic effects of current. Before going to solve this one, discuss some basic hints, some sort of hints. You must remember these things. That's a basic formula, mathematics. 1 by cos theta is what? Secant theta. 1 by cos theta is what? Secant theta. Let us consider x is equal to tan theta. Just to differentiate it, dx by theta, secant square theta. That also mathematics we know. Then another formula, sin 90 minus theta is equal to cos theta. That also well known formula. Integral cos theta d theta is equal to minus sin theta. That also we are going to apply these formulas in our part. Then another one is Biot-Savart's law. It's a very important 3 more questions. Just we borrow the equations to derive this big question. That's a magnetic field at a point dB is equal to mu naught by 4 by I dl sin theta by r square. This is called Biot-Savart's law. With the help of Biot-Savart's law, we can find it the magnetic field induction at a point due to current carrying conductor. Okay. By using these hints, we can derive and 5 more question. What's the question? Magnetic field at a point due to long infinite current carrying conductor. For example, let us consider there is a wire. X, Y. Carries a current I. Carries a current I. Okay. There is a point P. There is a point P at a distance A. Now we are going to find the magnetic field at P due to this current carrying conductor. When a current carries, there is a magnetic field around the wire. In the magnetic field, I am selecting a point P at a distance A from the wire. Now I am going to find the magnetic field at P. Okay, for that I am selecting a small segment, that is dl. Okay, I am selecting a small segment dl. Let it be Q, O. This is a small segment. This small segment of length, that is dl, produces a magnetic field at P is dB. It makes an angle theta. This angle, let it be phi. According to Biot-Savart's law, magnetic field at P due to small segment, you know the formula dB is equal to mu naught 4 by I dl sin theta by r square. Just to take this formula directly, that is dB is equal to mu naught by 4 by I dl sin theta by r square. This is a formula borrowed from this one. That's a Biot-Savart's law. Biot-Savart's law. Let it be equation 1. Okay. Now you consider this particular triangle. It makes an angle theta. This is phi. This is A. This is R. This is L. This length is L. This is R. Okay. Now you find the tan theta. Tan theta is what? Of tan phi, let it be tan phi. Opposite side, that is L by adjacent side. This is A. Then L is equal to what? A tan phi. I don't understand. This is 90 degree. Opposite to the 90 degree is the hypotenuse. This is the angle opposite side. That's opposite side. Another side is adjacent side. That is tan phi is equal to opposite side, adjacent side, L by E. That is A. Now I am going to integrate it. dl. X tan theta dx by d theta is equal to secant square theta. Just use it. That is A is the constant. Let it be constant. Tan phi secant square phi by d phi into d phi. Everybody understand? Everybody understand? Next one. Another case. Let us consider. Another case. That is what? Theta plus phi is equal to 90. How this is possible? Theta, phi, this 90. The total angle is 180. Then theta plus phi is equal to 180 minus 90, that is 90. Then what's the value here? That is, what's the value here? Theta is equal to what? 90 minus 5. Take both sides and sin theta, sin theta, that is sin 90 minus 5. Then sin 90 minus 5, cos phi. Sin 90 minus 5, that is cos phi. Just you take here. Sin theta is 4. Sin theta is 4. Now you consider another thing from the same thing. You find the cos phi. Just you find the cos phi. First of all, find the cos phi. That is what? Cos phi is equal to what? Cos phi adjacent side A, hypotenuse R. Then R is equal to what? A by cos phi. Just to bring this value here. Then R is equal to what? A 1 by cos secant phi. 1 by cos secant theta. 1 by cos phi is equal to secant phi. Everybody understand? Everybody understand? That means R cos phi sin theta, then dA. This value, instead of dA you substitute this sin theta, you substitute this value, or you substitute this value, dA from this value, sin theta from this value, or from this value. Just all those things will be substituted here. Then what will happen? That is dD is equal to mu naught by 4 by I, let it be I. dL is what? A secant square phi d phi. Sin theta is what? Cos phi. Whole thing divided by R A secant phi, that is A square secant square phi. Everybody understand? Now you cancel the term which are not necessary. Secant square we cancel, A cancel. That is the value mu naught I 4 pi A secant square cancelled, cos phi d phi. That is d b. This is the value. Okay. Actually, this is the magnetic field at a point P due to this small segment. What do we need? We need in the whole wire produces a magnetic field. Whole wire. This is what? Phi 1. This is what? Phi 2. I need this wire. The total wire produces a magnetic field. I am going to find it. How do you find it? Just integrate it. Just integrate this value. Then what will happen? That is integral dB is equal to mu naught I 4 pi a 4 pi a. Then integral cos phi d phi minus phi 1 plus phi 2. These are no variable. All those things are constant. Just to bring out from the integral. Then integrate it minus phi. Minus phi, this is phi 1. Limit here, phi 2 limit. This is a negative slope. This is a positive slope. Then only I put a minus sign here. Then b is equal to what? Mu naught I divided by 4 by a cos what? Minus sin phi. Cos phi integral minus sin theta. Okay. Then cos phi changes to minus sin phi. Limits minus phi 1 to plus phi 2. Just introduce upper limit minus lower limit. Minus into minus plus. Then b is equal to what? Mu naught I 4 pi a sin theta 1 plus sin phi 1 plus sin phi 2. This is some total magnetic field produced by a long infinite straight conductor. Okay, this is a theory part. Okay, this is a very important part. No? Just you follow. Again, you go through it, you can get your idea. So, board examination point of view is very important. At the same time, entrance point of view, we need concept clarity. I don't understand. Okay, bye. Actually, this is the second part. First part, theory about magnetic effects of current. Second part is the experimental setup. Third one is IIT related problems. IIT NEET previously asked problem. Now this is the experimental setup. Experiment. This is experiment. I am going to give the small experimental setup which was made by self. Okay. Here this is electromagnetic induction. Electromagnetic induction. What is electromagnetic induction? This was first introduced by Faraday. What is electromagnetic induction? Okay, let us consider the wire coil connected to the sensitive galvanometer. So galvanometer is a very sensitive. Since we are going to measure the small amount of current, okay, for that we are using sensitive galvanometer. There is a magnet, north pole and south pole. Around the magnet there is a magnetic lines of forces, starts from north and terminate at south. So magnetic lines of forces. Just to bring this magnet inside the coil, just to bring this magnet inside the coil, what will happen during the process? There is a change in magnetic flux around the magnetic field around the magnet. According to the Faraday, whenever there is a change in magnetic field, EMF is induced, due to which current flows. Actually, this is the basic concept used in the generators. Nowadays, we are using this concept in all the fields. Okay, it's a very simple concept, but the application is large enough. Okay, thankful to our very famous scientist, Faraday. Okay, the same thing, and we can do some sort of small experiment. This is a wire. The wire is connected to battery and key. This is a coil. This is a coil. The current flows. There is another wire. This wire is connected with the galvanometer. What galvanometer? It's a sensitive galvanometer. Okay. Now if you switch on, the current flows. Gradually current increases. Gradually current increases means the flux, that is magnetic field around the wire, is also increasing. That is magnetic flux changes, which is linked with the another coil. According to Megan Faraday, whenever there is a change in magnetic flux, EMF is induced due to which current flows, then galvanometer shows some sort of deflections. Then next, switch off. Switch off means what? Current decreases. Then the magnetic flux linked with this particular coil withdrawing, that is withdrawing. Here also there is a change in magnetic flux, EMF induced here, current flows, then galvanometer deflects. Understand? Okay. When we switch on, switch off, there is a change in, that is a deflection in the galvanometer. Deflection in the galvanometer. Are you understand? During the study process, in between switch on and switch off, during the study process, there will be no change in deflection. The galvanometer will not change. The deflection in the galvanometer is 0. Okay, this was explained. This can be explained with the help of small experimental setup. This was the design. This is a coil. This is a coil, copper wire. Is a switch. I am going to connect it a battery. Listen, 9-volt battery. I am connecting here. Just we connect it. Just I connected battery. This is a wire. Switch on. What will happen? This is a bit. I switch off this. Correct. Then you can see the clear. This is what? This is the wire, copper wire. The copper wire is connected to the battery. Then current flows. The current flowing through the wire. This can be shown with the help of the LED light is glowing here. Okay. What will happen? Think here. Just to bring the another wire. Another wire. This is another wire. This is connected to the galvanometer. We must connect it to galvanometer. Instead of galvanometer, connect it to LED. Just no, there is no connection. Just bring this close to light close. That means the magnetic flux in the wire can be changed with the help of another wire. That's all. There is a change in wire. There is a change. Magnetic flux can be changed. The EMF is induced. This can be visualized in better manner. Just to see here, this is the wire. Just to bring the another wire, light is glowing. Light is glowing. That means the flux in a one wire can be changed with the help of the another wire. This can be indicated with the LED lamp. This is a small experimental setup. This is a small experimental setup which was designed by me. Okay, in that manner we can explain easily electromagnetic induction. Electromagnetic induction. Are you able to follow? If you want more explanations related to this topic, comment in the comment box. Comment your doubts in the comment box. At the same time, just you subscribe this channel. Then only you can interact more. You can see more videos automatically. That is, there may be a live interaction between you and me. Okay, just first you subscribe it, then you can follow this. Okay, bye. Thanks a lot. Hi. Morning. In this video, the first part is related to theory. The magnetic field due to a long straight current carrying conductor. Second part is the experimental setup. That's electromagnetic induction may be discussed with the help of the small experiment which was made by me. The third part is the IIT NEET problems, related problems about this particular topic. This question was asked in IIT 2000. In the 2000, this question was asked. It's a very important question. It's a very simple. Very simple. Just we see how do we discuss. Let us consider that question is an infinite long conductor PQR. Long infinite conductor PQR is bent in the form at right angles in the form at right angle in the form of at right angle 90 degree right angle. Current I flows through PQR. The current flowing through the wire is I. The magnetic field at M is V1. The magnetic field at M due to passage of current in the wire is V1. Everybody understand? Second part of this problem. Another wire QS. There is another wire. This is another wire QS. Another wire QS carries current. The current that is flowing here is I by 2. Carries current I by 2 connected at Q. The magnetic field at M is V2. Everybody understand? V1 means just you consider this particular wire alone. PQR alone produces a magnetic field at M is V1. V2 means what? This wire as well as this wire, the net effect of the whole segment produces some sort of magnetic field at M, that is called V2. Okay, what they asked? They asked to find the value of V1 by V2. It's a very simple question. I'll get some sort of shortcut. Instead of doing usage of formula, instead of using the formula we can derive, it will take some sort of long steps. For that, I am going to do small shortcut here. Okay, everybody understand? Here, the current is I. This is the current I by 2. Okay, the net effect, the total magnetic field, the overall, this is called V2. V2. This is the nothing but the V2 is the total magnetic field produced at this particular point. That is magnetic field due to PQ. Magnetic field due to QR. Magnetic field due to QS. I don't understand. There is a magnetic field due to this part, due to this part, due to this part. The total effect is the V2. Okay. What's the magnetic field due to this particular part alone? They gave this value, that is V1. This value is V1. V1. What is this value? The magnetic field due to this segment, that is QR, is 0 since there will be no effect, since the current is along the direction through the point. When a wire passes through the particular point where we are going to find the magnetic field, it becomes 0. There is no effect. Then this alone, that is V2, that is PQ, that is QS, the effect alone is what? That is half of V1. Have you understand? Half of V1. This is I by 2. Half of this effect will provide this one. I don't understand. Then what will happen? That is V1, 1 plus 1 by 2 that is B1 3 by 2, that is B1 by B2 2 by 3. This is very simple by using the shortcut method. But we can derive this with the help of the formula that is used to. That's a formula used. It is little bit difficult. It will take some sort of more for our 5 steps alone. But here within 2 steps we can find it easily. This is a question was asked IIT 2000. It's a very important problem. We will discuss more problems in the forthcoming sessions. Okay, bye.